Now, now here we have a question, example question I'm taking, that is 1.6. Okay, this question came in the exam. That's the reason I'm taking this question. So there is an equilateral triangle. He has taken a equilateral triangle like this. There is an equilateral triangle, point A, B, and C. There are three charges at three different points. One is all the charges are equal. Q1 equal to Q, Q2 is also equal to Q, Q3 is also equal to 3. Q. All the charges are equal. He says consider three charges, Q1, Q2, Q3, each equal to Q at the vertices of an equilateral triangle whose length is L. This is on page number 16. Page number 16, and question number is example question number 1.6. This question. Now he says that whose length is L. What is the force on a charge Q, which is at that is of the same sign here. That is at the centroid of the triangle. So at the centroid of the triangle. This is what is the centroid of a triangle? Can I leave and join again? Yeah, it's okay. Okay, leave the meeting and join again. Not a problem. Anyways, the meeting is open. Now here, what is the centroid? Centroid is the point of intersection of the medians of a triangle. What are medians again? Which divides the other side into two equal parts. They are said to be the medians. See here, this makes exactly two equal parts. Now, so here we have y is the centroid. Okay, so here this force is F1. Now, and this force is F2. This force is F3. F1, F2, and F3. Now, L is the length. So, how much will be the angle here? Suppose this will be 120 degrees. Three forces now. F1 is downwards. This is F2. This is F3. So first I want to find out the resultant vector. How will I find out the resultant vector of F2 and F3? See, once again, F2 is acting downwards, F1 is acting downwards, and F2 is acting this way, and F3 is acting this way. And now we have to find out the resultant of F2 and F3. The angle is 120 degrees. Angle between F2 and F3 is 120 degrees. So it's like a parallelogram. It's like a parallelogram. So we have the formula, right? R is equal to under root of, what is the formula? P square plus Q square plus 2PQ cos theta. Do you remember this one?
Yes, sir.
So here we have the resultant vector R is equal to what? Here we have F1 square plus F2 square plus 2F1 F2 cos 120 degrees. Got it? So, and also, what is this length? So we have AD. So in a triangle, suppose if O is the centroid, go back to mathematics. If O is the centroid, then what happens? This will be 2/3 and this will be 1/3. You remember that now? So is that clear? So once again, if suppose this is the centroid, A to O is 2/3 times of O to D. Got it? Is that clear? So
yes, sir.
Yeah, AD we can write AO equal to 2/3 times of OD. Clear? As per the that one. So that means this is 2/3 and this is 1/3. This is 1/3 times and this is 2/3 times. Now also we know the forces, because all the charges are equal. Forces will be also same. What is that? F1 will be equal to F2, which will be also equal to F3, which will be equal to F. So R equal to how much? Under root of, I am taking this F square plus 2F square cos 120 degrees. How much is cos 120? How much is cos 120?
1 or 0.
How will you solve that? Cos 120. Mathematics students or non-mathematics students. So cos 120 can be written as cos 180 minus theta. Cos 180 minus
minus half.
Equal to what? Minus cos 60. That is equal to minus 1/2, right? Is that clear?
Yes.
Minus 1/2.
Yes, sir.
We are going to substitute that. R equal to how much? Under root of F square plus F square, 2F square plus 2F square into how much? 1 by 2 minus 1 by 2. So R is equal to how much? Under root of 2F square. This time 2 and 2 will go away, minus F square equal to R is equal to under root of F square. R is equal to F. Means the force is again F. Means what? The force which is going up and down is same. Got it? The force which is going up and which is going down, both the forces are same. Is it not? Are you understanding all of you?
Sir. Yeah, sir.
Yeah. So, so here it is clear that the sum is 0. So the downward, so this is what? This was, if you see carefully, this is F2, this is F3, this is F, and this is F1. F1 is again equal to F. So upward force equal to downward force, is it not? When upward force is equal to downward force, so what will happen? The sum is 0. The sum of all the forces is 0. Understood? Is that clear?
Yes, sir.
Yeah, this is not explained like that in the textbook. That is a problem I am telling you. If you are able to do example questions, you can definitely crack any questions. Exercise questions are easy than example questions. Got it? Please do copy this one.
Yes, sir.
Go to the next one then.
Done, sir.
Done. Okay. So I'll go directly to the electric field now. Okay. So you have to try some more questions from the from the worksheets or from the past papers. You try some more questions. Or now make it a strategy now. First, try to complete the revision first. Don't directly start solving the past papers. Again and again, I'm telling you, try to take 2 chapters on a day. Like maybe it's a physics or chemistry combination, or maybe it is a biophysics combination or math physics combination. Anything. Make one combination. Try to complete at the earliest. If you're able to do 3, also not a problem. Try to complete a day like that. So after that, you will have at least 1 week. You can sit and solve past papers. Got my point? Like day in the morning, one past paper, maybe physics paper. Afternoon, you can do chemistry paper like that. You can do it that way. That is a strategy you follow, because once you start January, then again pre-board exams will start. There is no time to prepare. Only you have to be limited with one subject. At that time also, you can first revise, then start solving some past papers there also. Got it?
Yes, sir.
Now this 10 days and next month will be very crucial, because maybe as per the circular which we got from CBSE, and maybe we are waiting for Indian consulates In Indian consulate, we have education wing who takes care of these practical exams and all theory exams. So there is a meeting, not now, because all the schools are closed now. January 1st week, there will be a meeting with all the schools and we fix the dates with the external and internal examiner. That also will be coming from CBSE only. This last year also they gave from CBSE. This year also it might come from CBSE. But the dates we have to finalize. Okay, external and internal is now decided by those CBSE people now. Now, the dates we will fix it. Mostly from 21 on, 21st of January onwards. 21st to maybe 5th of February. Maximum, max. The 15 days we will try to finish off all the practicals. Got it? So, that is the strategy now. You think about it, keep all these things in the mind and start planning and executing. That is important. Now, we'll go to the electric field now. What is electric field? Anyone?
Sir, pivots are as scheduled.
As scheduled. There is no change.
Okay.
No change. And it will not change also.
Yes.
Don't mean but this is not like matches and all. Okay. Now,
Yeah, that's good.
yeah. Now next one is what? Electric field. What is electric field? The second part now.
So it's the
re-
field around which an electric effect can be felt.
Anyone? Any other definition? Yes. Any other definition?
Sir, a region around a magnet in which we feel and in which a force is felt.
The space around the charge where its influence can be felt. Simple definition. The space around the charge where its influence can be felt is known as electric field. Now, suppose there is a charge. There is a charge here. Okay, there is a charge here. The electric field is like this. It goes in all the directions. Okay, the space around the charge where its influence can be felt is said to be electric field. Okay. Now there is one more definition as per the textbook. As per the textbook, he says that now here it is Q0. What is Q0? Q0 is said to be unit positive charge. 1 second. Huh? I don't know. You are mixing everything. I cannot explain now. Now, here it is Q0 is said to be unit positive charge. Okay. Q0. One second. So Q0 is what? Q0 is said to be unit positive charge. What is unit positive charge? Can anyone tell me about this? Unit positive charge. Q0 is said to be unit positive charge. What is it? Unit positive charge is only one charge. One charge is not available in the universe. It's not possible. Do you believe that one, like our Ashas is going to moon and cooking biryani and eating there? No one can believe that. Yeah. So no one will believe that. Okay. So it's like one charge. One charge is not possible in the universe. Only it is a hypothetical phenomenon. Then why do we bring this Q0? What is the necessity? Because if we know what is the force experienced by Q0, one charge, then we can find out for any number of charges. If we know that what is the force experienced by one charge, then we can find out for n number of charges. That is the reason we brought this hypothetical phenomenon. Now there is a unit positive charge here. Now what is the force experienced by unit positive charge? Is said to be electric field. Once again, there are two definitions. What are they? Number one, the space around the charge where its influence can be felt is said to be electric field, or the force experienced. The force experienced. There are two ways we can say this word: force experienced by Q0 or force exerted by charge Q on Q0. Once again, force experienced by Q0 under the influence of Q, or force exerted by Q on Q0. That is said to be electric field. Is that clear? That is said to be electric field.
Yes, sir.
Now, so what is the formula for electric field? We have E is equal to, use a vector quantity again. E is equal to 1 by 4 pi epsilon 0 Q by R square. Okay, this is the formula. Q by R square. Again, you can write R cap also if you want. Q by R square into R cap. Now, so next one. After that, we have that is electric field. We can write this is the formula, and F is equal to Q into E. E is equal to F by Q. E is equal to F by Q, or F is equal to, we have formula F is equal to E into Q, and measured in Newton per Coulomb. Okay, it's measured in Newton per Coulomb. Okay, measured in Newton per Coulomb, and it is a vector quantity. Electric field is a vector quantity. Clear? Electric field is a vector quantity. Next one. First, I'll write the electric field due to a system of charges. Then I will discuss about the physical significance. Then I will discuss the properties of electric lines of forces. Now, again, so electric field due to system of charges. We'll do a numerical also on this. Electric field due to system of charges. Maybe my pace is little high. Are you able to understand, all of you?
Yes, sir.
Yes, sir, we're able
Yes.
to understand.
Yes, sir.
Yeah, I cannot go slow now because I need to complete the chapters now. Okay, there is no time, much time left to do this. Okay, once it is done, I can start with my past papers now. Solving of past papers with you. One complete paper, one day at least. I'll try to do that. Okay, or if not, at least 50% of paper of the one past paper I can try to solve. Okay, now electric field due to system of charges. Now suppose there is a charge P at a point, and we have charges here Q1, and here we have Q2, and here we have Q3. So this is exerting a force on this one. This is exerting a force on this one. This is exerting a force on this one. So what is the force at point P? So here we don't write force, it is like electric field. This is E1, this is E2, and this is E3. Okay, E1, E2, and E3. What is the formula of E1? E1 is equal to what? E1 is equal to 1 by 4 pi epsilon 0.
4 pi epsilon 0
into
Q1 by R1 pi
This is
square.
R1P, R2P, R3P. Clear? R1P square, R1P square into R1P cap. Okay, because it's a vector quantity. Similarly, we have again 1 by 4 pi epsilon 0 into Q2 by R2P square into R2P cap. What happened? Close that for some time, and listen here. Now Q3 by R3P square into R3P cap. Okay, so this is the one. So when we take common here, it will become E1 is equal to what? K into Q1 by R1P square plus Q2 by R2P square plus Q3 by R3P square. This is the formula. Okay, R3P square. Now R3P square. Now so here we can write in general formula. What is that? E1 is equal to what? K into summation I is equal to 1 to n Qi by RIP square. Okay, R1, yeah, RIP square into R1 RIP cap. Okay, this is the formula what you get. This is general formula. This is the general formula. Clear with you all? The concept of electric field and system of particles.
Yes,
Yes,
sir.
sir.
Okay.
Done, sir.
Okay. Now, next one. Next one is physical significance. 4 points in physical significance and 5 points in properties. Physical significance. You can expect this in session reasoning thing, this type of questions. So first one, what happens is, it says that suppose when the electrons accelerate here, when the electron, these are the charges or some electrons accelerates here in the antenna. Simple example. So this gives the concept of electromagnetic wave actually. When the electrons accelerate in the antenna, what happens? Electromagnetic wave is produced. Electromagnetic wave is produced. Means the charge, what happens when the electrons are accelerating in the antenna, electromagnetic wave is produced, which will travel with a force F and exert a force on second charge. Like suppose you can take Q1 here, exert a force on the second charge. Got it? This gives rise to the concept of electromagnetic waves. Once again, when the electrons are accelerating in an antenna or in an object, what happens? Electromagnetic wave is produced, which will travel with a velocity v. Which will travel with velocity v. V means here it is c. C means 3 into 10 to the power of 8 meter per second. Which will travel with velocity v and exert a force on the charge in the second antenna. That is how the electromagnetic wave is detected in the second antenna. Got it? Is that clear? This is the first one. The second one is it has dynamics of its own. It has dynamics of its own. What is the meaning of this? Dynamics of its own. The meaning is like see, a mass plays an important role in mechanics. Do you agree this one, all of you? Mass in linear motion.
Yes, sir.
In mechanics, in linear motion, mass plays an important role in the mechanics. Similarly, moment of inertia plays an important role in rotational motion. Same way, electromagnetic wave also plays an important electric field plays the same role in electrodynamics. Simple example I will give. I think you have seen this Gajini movie. There is an old movie. Have you seen this one? Anyone? It's a Tamil movie.
Which movie? Yeah, sir.
Gajini, after that first started in Tamil, then it came in Hindi also.
Yes, sir. Yes, sir.
Yeah, you might have seen, there is I think in Tamil it is Surya. Okay. The role played by Surya in Tamil is the same role played by Amir Khan in Hindi, right?
Yes, sir.
The same role.
Yes, sir.
The same role. Same way, the role played by mass in linear motion is same as the role played by moment of inertia in rotational motion. And it is also same like the role played by electric field in electrodynamics. Got it now? Is that clear? Electric field in electrodynamics. I repeat again, the role played by mass in linear motion is same as the role played by moment of inertia in rotational motion is same as the role played by electric field in electrodynamics. Got it? Third one.
Yes, sir.
The third one is what? Third one is it can transport energy. It can transport energy from one point to another point. Fourth point is what? Fourth point is it is Faraday's central concept. Okay. So these are the 3 points. Just remember this one. Now I'm going to the electric field concept. That is properties of electric field. Properties of electric field. Next is properties of electric field. Properties of electric field. Electric lines of forces, they start from positive charge. Electric lines of forces, they start from positive charge like this. They start from positive charge and they end at the negative charge. Okay. They end at negative charge. They start from positive charge and they end at the negative charge. Okay. Now, like charges repel and unlike charges attract each other. Okay, you know that. So if you draw the positive charge and positive charge like this, see how it will be. or negative, negative also will be same. If you take a positive and a negative, what happens here? This is positive and negative. Understood now?
Yes, sir.
Sir, for the properties of electric field, the second one, both are plus Q.
Here both are positive or it can be both negative. They repel. Here repulsion is taking place. This is repulsion and here it is attraction. Here. This is the first point only. It comes under first point. Can I erase these points? These points here.
Yes, sir.
Yes, sir.
So here, quickly we'll do one question on this also, electric lines of forces. Second one, it forms continuous curves without break. Continuous curves. Okay, they form continuous curves without break. Simple example I will tell you for this. Suppose you are talking on a mobile phone and you are walking at the same time. Does the signal break?
No, sir.
Like you are walking in a room, one room, from one point to another point. Does it break? It won't break, right? The signal won't break. We are walking
Yes.
in the same room. You're not going from one first floor to second floor. Just walking in the same room. So what will happen? It's a continuous curves. Okay, it's not like breaks. Third one is they don't form closed loops. Okay, they do not form closed loops. Okay, fourth one is they never
don't intersect.
they never intersect each other. If they intersect each other, that becomes absurd. Okay, intersect each other. There will be two directions, which is not possible. Fifth one, they are normal. They are normal to the surface. They are normal to the surface. They are normal or perpendicular to the surface. Now, once after writing these 5 points, I'll tell you what to do now. Go to this question. Go to additional question, page number 48, 1.26. Page 48, 1.26 question. All of you. Open your textbook, go to that point, go to that one.
Yes, sir.
Yes, sir.
Now, so here 1.26, the first one. Do you think the first one is correct? The conductor
No, sir.
A. Why? Why?
No,
sir?
sir.
Why?
Because it's not normal to the surface.
Very good. Or very good. So according to the fifth point, okay, we write the reason for that. Write the reason for A is because no, that is not correct because the electric field is not normal to the surface. Number one. Second one. What about the second one?
So light charges.
It's not.
The light charges repel.
Right, repel, but here it is different, right?
No,
So-
sir.
Yeah.
At the end, it's positive, positive, positive. So
Yeah, so
positive,
it is
negative.
not possible. So write the point. Like charges repel. No, the answer is no. So like charges repel. What about the third one?
Third one is proper. Sir.
Yes.
It's correct.
Repel.
It obeys.
Yes, sir.
It obeys the first rule. What about the D?
So
No.
No,
it's forming.
they repel.
It does not form closed loops.
And positive to
They
They
don't
should not
intersect,
intersect.
also repel. They
intersect.
don't attract.
Yeah, positive
And they
to repel.
repel.
Yeah. What about the fifth one?
So no, because they're not normal to the surface
And
and they don't form closed loops.
very good. They do not form closed loops. Okay, that is very important. So there are some circles inside it, which is not possible. So write all the answers for these five points. Got it? Such type of question will come in the MCQ or maybe assertion reasoning. Got it? So this is the best example. Whenever you study these 5 points, do this example. You will understand. Okay? These 5 points you have to do. Now. Okay, then going to the next one. Can I erase this one?
Yes, sir.
Yes,
Okay.
sir.
Just I will discuss what is electric dipole and electric dipole moment, then I will stop here. So remaining 3 derivations I will be doing tomorrow. All the derivations I will try to finish off tomorrow, this chapter. Now, so here we have electric dipole. What is electric dipole? What?
Two equal and opposite charges separated by a finite distance.
Very good. 2 equal and opposite charges. 2 equal and opposite charges separated by a finite distance. Separated by a finite distance. Okay, is said to be electric dipole. What is electric dipole moment then? Electric dipole moment is P. Okay, it says that the product of charge and the distance between them. And the distance between them. Product of charge and the distance between them is said to be electric dipole moment. Now here, like suppose there are 2 charges here. This is positive charge and this is negative charge separated by a distance of 2a. So what is that? P is equal to what? 2qa. That is a formula. And the formula is Coulomb meter. Okay. And the electric dipole moment will be from minus P to plus P. It is from minus P to plus P. Clear?
Yes, sir.
Yeah.
Yes, sir. The product of charge and the distance between them is said to be electric dipole moment, and it is P is equal to 2qa, and the formula is units are Coulomb meter. Okay, not centimeter, it is Coulomb meter. Got it, all of you?
Yes, sir.
Yes, sir.
Okay, then for today we will stop here, and tomorrow I'll be doing 3 derivations from electric field, then flux, then 3 derivations from the next one. That is about the flux thing. Clear?
Yes, sir.
So join on time.
Yes, sir.
And Ashad, I'll be waiting for your paper.
Yeah, sir.
Okay, so please do send me. Then I'll correct the paper and I'll send it to you. And all of you, please download the folder or physics folder and start solving the questions also. Okay.
Yes, sir.
Yes, sir.
Thank you
Yes,
so much.
sir.
Thank you.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Sir, I wanted to ask you something.
Yeah, tell me.
Sir, I actually wanted the 10th grade ka board wala
10th
mark
grade
sheet.
वाला. What you want?
Yes.
10th grade का mark sheet चाहिए.
Yes, sir. How will I get it?
That you will get it from school, no?
सर मैंने ईमेल किया है 3 दिन हो गए अभी तक कुछ
No,
रिप्लाई
because
नहीं
they
है.
are on leave. सब मेरे जैसा काम करेंगे क्या सब लोग ऑफिस में holidays में? No one is responding also to my mails, you know. I have taken
Same.
approval from the principal now. From morning I have sent one mail to principal. Like I am taking directly approval from principal also. Actually, I am also not supposed to work. Is it not?
Yeah.
Okay. So
Okay.